Hello, my name is Ji Jung, and I'm an 11th grade student currently attending the American National School of Vienna. For my IGO project submission, I would like to present my research on examining the industrial pollution of the Han and Donau rivers in South Korea and Austria. To introduce the topic, with global warming becoming a prominent threat to humanity, industrial pollution, which happens to be the major leading cause of it, must be mitigated. And the study hopes to find a solution to that by comparatively examining the Han River and the Donau River. This is significant because the Han River and Donau River not only differ by nations, but they differ by continents. And by comparing these rivers of vastly different settings, I'm able to consider various characteristics that can be served as indicators of industrial pollution. For the study area, the specific data collection sites are shown as a table to the right, with different sites being selected for dissolved oxygen, pH, and total dissolved solids data collection. The satellite images of the data collection sites are provided as well, with the top being the DO data collection sites and the bottom being the pH and the TDS data collection sites. For methodology, a total of 150 trials were conducted for each data collection site for each parameter, amounting up to be a total of 1,800 trials per each parameter. And for dissolved oxygen, this was done so with a 1-minute interval because it's known to be a more constant value. Whereas for the pH and TDS, it was done it requires being done in situ because especially pH is known to be a very volatile value, and hence it was a continual recording method was utilized with data being collected every 30 seconds. For quality evaluation, the Han River is known to be significantly polluted compared to the Donau River because industrialization has continued in Korea since the 1960s, leading to it becoming the 43rd highest drug contaminated river. On the other hand, the Donau River is considered to be generally ecologically and chemically in good condition, with 97.7% of the water being considered as in excellent quality. For a summary of the data collection, the Han River would appear to be more contaminated than the Donau River as expected, as the average DO values of the data collected was 6.8, whereas the Donau it was a significantly higher of 7.5. Similarly, the pH value was lower in the Han River of 7.649, whereas in the Donau River it was 8.534. However, a limitation of the study will be that the TDS also happened to be lower than the Donau for the Han River than the Donau River, which would indicate to the contrary that the Donau River is more polluted than the Han River. To analyze this further, the human population density was considered as another metric that would connect to industrial pollution because the more population within an area, obviously the more pollution that would happen. And as expected, the Han River was appeared to be significantly more populated than the Donau River, with the population density of the nearby data collection sites being ranging from 8,400 to 10,900 people per square kilometer, whereas the Donau River it was generally constant of 1,600. The air quality index was also considered because part of industrial pollution is when pollutants are being released into the air to contaminate the atmosphere, and the CAI was utilized as the specific index in this case, and it revealed that the Han River was once again significantly more polluted than the Donau River, even the atmosphere, with the CAI value being 53 and 84, which was significantly higher than the average values of data collection sites in the Donau River, which was approximately 27. To analyze the relationship between the parameters, a correlation matrix was utilized, and because the magnitude of the R values was all above 0.6, it can be assumed that all displayed a high relationship, and therefore all can serve as indicators of industrial pollution. Additionally, a machine learning model was implemented for using the Donau Han River, but unfortunately, it turned out to be quite inaccurate because the RMSE and the MAE values were each greater than 40. And to analyze why the model had failed, a clustering analysis was conducted where a scatter plot was drawn and then in clusters were attempted to be identified. And it showed that the Han River, which was used for a testing set, the Donau River for the training set, was of different clusters. So when only training the model with one, it would obviously provide different predictions than the actual testing set, which was of a different cluster. And this clustering became especially prominent when a PCA was applied as a dimensionality reduction technique. To improve this, a generalized machine learning model was created with additional data from rivers being gathered from public data online for a total of 66 rivers from the past decade and 45 rivers from the past 6 years. Additionally, more models were implemented from linear models, support vector regressor models, and model ensembles. Additionally, with more feature selection methods and dimensionality reduction techniques for a total of over 30,000 different combinations. And as you can see, the errors for all of these different models were significantly low, generally being lower than 3 for the MAE and 50 for not the RMSE but the MSE, which indicates towards the model being very, very accurate. In conclusion, trends between the physicochemical parameters are identified in order to create an accurate model to estimate AQI. And this is especially significant because an AQI meters generally cost up to tens of thousands of dollars, but by presenting a cost-effective model that any individual can utilize, hopefully I'm able to raise awareness about the severe issue of climate change that continues to exacerbate. Additionally, it's possible to be used for research purposes because these are publicly available models, and AQI data is very limited due to obviously it's the high cost needed to collect the data and also the difficult procedure that they must undergo. Lastly, future improvements are also possible where neural networks or more complicated models can be implemented to raise the accuracy or the reliability of the models. And additionally, data visualization such as 3D models or heat maps can be implemented to further examine the relationship between the parameters. These are the references that were used for the research, and thank you for watching this presentation.